is 24.5, where this HA is 10 raised to 5 now and K is tending to infinity. So instantaneous reaction, infinitely fast reaction you can say. So this mass balance PA in minus PA out, CB in minus CB out, Fg by pi here, Fl by Bct here. B is again the stoichiometric coefficient which is important. CB in 1000 minus 100, PA2 minus PA1. This is CB1 minus CB2. CB1, CB2. This value will be less. This is getting consumed throughout the column. For any value of PA, you can write this equation and you get CB is equal to 50.56 plus 90 minus 0.9 PA divided by 16.2, and this will be valid throughout the column. At PA2 is equal to 1000, you can calculate CB2 and that comes out to be 5.555. Same method again, calculate MH. We have calculated MH values, then enhancement factor values in tank type reactors, which was throughout the tank. Here in the tower type, we have to calculate it at the top and at the bottom. So at bottom, CBHA by PAI, we take this value, so this can be 1000 or lower. So this will be 556.55 or higher value. Here EI, as MH is infinity, so EI will always be less than MH by 5 or MH whatever value. So this E is EI and that is this value 556.55. As MH is equal to infinity throughout the tower, of course, because this K is in the numerator and this value is infinity. So EI less than MH by 5 will be valid throughout the tower. So this value of E we can use throughout the tower. So here HA value, this KGA, KA, all these values have been written. Now look carefully into the calculations. Now here we are calculating dPA by minus RA, this integral. Okay, dPA by minus RA. So what we want is rate is PA divided by total resistance. PA values we have taken 100 to 1000. So numerical method of integration remains same. Calculate CB values. 1 upon KGA constant. HA by KLA into E. Now here HA is constant, KLA is constant, but this E value is changing, as here you have PA. So PAI value, corresponding value of PA you take, and that will be the corresponding calculated value or some higher value. If PA is equal to PAI, then these values. So as E is changing, all these values are changing. Okay, here HA and KLA is constant, whereas enhancement factor is changing because this PA is changing. Then HA by K into CB into FL. Okay, as K is tending to infinity, these values are 0. So this resistance you need not bother about. So this is neglected. But to understand the problem and to remember all the terms we have to use for resistances R1, R2, R3, we will prefer to write this, then calculate and then mention. So total resistance, this R1, R2, R3 added. So the resistance is changing throughout That means rate is PA, corresponding value of PA divided by resistance. Okay. So this value PA by total resistance is giving us rate. So this is varying. Then you calculate 1 upon rate. So we have seen here design equation, volume is Fg by pi dPa by minus Ra value, and minus Ra value is Pa by resistance in this case, and this we have calculated. Then in integral sign we have integral Pa1 to Pa2 dPa by minus Ra, that is rate. So we calculate 1 upon rate. So integral is 1 upon minus Ra 4 times prime, that is 1 upon rate, and this we are evaluating from, it is varying from 1000 to 100. So in the beginning it is 1000 and this is 100. So Pa1 to Pa2 we write in our equation. So Pa2 minus Pa1, 1000 minus 100. In this case it is not 1000 minus 100 because integral is not simply dPa and rate is not constant now, it is varying throughout as Pa is varying. So it is under integral sign. So we integrate between these limits Pa1 to Pa2, 100 to 1000. This value of integral again comes out to be this. So once again we will see this value we have calculated using this n plus 1 points, 10 points. So n is 9, 9 by 3, 3. So 3 by 8 into h is 1000 minus 100, 900 divided by 9, that is 100. So 3 by 8 into 100, and f0 and fn, first and last point is there, and in between you have this combination of sequence 332, 332. Now here this value 3 times this, 3 times this, 2 times this, 3 times, 3 times, 2 times, 3 times, 3 times, and plus the last value fn. So if you calculate this, the value of integral is 7.032, and in design equation Fg by pi I know 0.9, this value is 10 raised to 5, 7.032. If I multiply by this I get 6.33 meter cube. So different values of Ka, different values of Ha, we are calculating the volume of tower reactor required, and we can always find the height depending on how much is the cross sectional area. When we will go for final design, what cross sectional area will prefer, and accordingly you can find out the height.